Hello, welcome to Instant Mechanics. Today we are looking at integration by partial fraction. So suppose we have integral of x plus 1 on x squared minus 3x plus 2 dx, and we are to integrate this function with respect to x. How are we going to do this? When we look at this function, it does not obey the rule integral of f prime of x, f prime of what, or f of x dx, where the derivative of f of x is the numerator. It does not obey such rule because looking at this function, the derivative of x squared minus 3x plus 2 will be 2x minus 3, and there's no way you can manipulate this numerator to obey this. Are we okay? So in such cases, we are going to use the partial fraction approach. The partial fraction approach. And before we start with the partial fraction, there are some things we must take note of. First, if you are given the function, the numerator, the degree of x or the degree of the variable of the numerator must be lower than the denominator. Are you okay? So one, numerator, take into consideration all these parameters. Numerator must be of lower degree than the denominator. With that, we can then proceed with our partial fraction. For example, this example is a perfect example. The denominator is raised to the power, the highest power is squared, the x is squared, and with the numerator, it is x raised to the power what? 1. Are we okay? If the numerator is equal or greater than the denominator, we then use long division to reduce the power of the numerator. For example, if we have x cubed minus 2x plus 2 on, let's say, x squared plus 2. In this way, the numerator has a greater power more than the denominator. So we use long division to reduce the power of the numerator. Are we okay? We will tackle questions like this. So the second point, we should always factorize the denominator into prime factors. We have to factorize the denominator into prime factors. Are we okay? Send the denominator into 8 factors. For example, if we take this, for instance, integral of x plus 1 on x squared minus 3x plus 2. In order to use partial fraction for this function, first break down the denominator into 8 prime factors. And what are the prime factors for this? This is equal to integral of x plus 1. Using factorization, the factors of this are going to be x minus 1 and x minus what? 2. This is 8 prime what? Factors. Are we good? So we cannot work it in such form. We have to break it down into 8 prime factors if possible, because there will be some functions or some of the denominator which cannot be broken down into 8 factors. But if it is possible, you have to break it down into 8 prime factors. Are we good? So now, if we break it down into prime factors, what do we do? Or if it is not possible to break down, what do we do? So we consider this. If the factors are linear, if they are linear factors, if we have linear factors, meaning factors in the form ax plus b, such as this plus a certain b, then we are going to express the partial fraction in a way a over that, which is ax plus b. So after breaking down into prime factors, if it is linear factor, which is x raised to the power 1. In this form, we are going to express the partial fraction in this approach. If it is quadratic, what do we do? If, for example, this cannot be broken down into 8 prime factors, and let's assume it is just this, what do we do? So if it is quadratic, how do we solve the partial fraction? Then we are going to break it down into a on the entire function, x squared minus 3x plus what? 2, which is the same as a on a certain ax squared plus bx plus c. Are we okay? That's for the quadratic part. What if it is in a different form? Let's look at all the forms that we have. So the second form, if we cannot get a linear or we are not getting anything quadratic, how do we go by this? So if, for example, the third point, we are having factors in the form ax plus b raised to the power n. Now it is linear factors, but it is raised to the power n. Then we are going to express the partial fraction in the form a on the first part, which is ax plus b, then plus b, ax plus b, we increase the power by 1, which is 2, plus until we get to a certain z on ax plus b raised to the power the last button. Are we okay? So first, if it is in this part, this is how we are going to break the partial fractions down. Are we good? All right, so with this idea, we can now proceed. So for example, if we are given an example, integral of x squared on x plus 1, then x minus 1 all squared. This x minus 1 is a linear factor, but here it is raised to the power certain n, which is 2, meaning we are going to express it. The first one is just a linear factor, so it is going to take a to the power of that, s plus 1. We come to the second linear, but here to the power 2. So b is now going to take the first part, which is minus 1 raised to the power 1, plus c, which is going to take, let's say, x, that is x minus 1 raised to the power what? 2 in this form. Are we good? So this is how we express the product or the quadratic approach. So example 1, if we are to find integral of x plus 1 on x squared minus 3x plus 2 dx, we are to integrate this. How do we go by it? First, we know that this is the same as integral. We have to break this down into 8 factors. So, which is x plus 1. On breaking down this, it is going to give us x minus 1, x minus 2 dx. So this is now my question. From partial fraction, I can take this and say that x plus 1 on x minus 1, x minus 2 is the same as here, since they are just linear factors, a is going to take x minus 1 plus b x minus 2 in this form. Are we okay? So since the LCM is the same for this part, can we say our x plus 1 from partial fraction, this will multiply that, ax minus 2, then this will multiply that, b x minus 1. So to find the value of a and b, when x is equal to 1, this one will make b go towards 0. Here will be, so 1 plus 1 into a by 1 minus 2. That will be plus b 1 minus 1. So we are getting 2 equal to negative a. Therefore, our a is equal to negative 2. Now we want to find the value of b. When x is equal to 2, it will render a to be what? 0. So when x is equal to 2, when x is equal to 2, then we are going to put 2 in place of x. That will be 2 plus 1 equal to a, 2 minus 2 plus b, 2 minus 1. And here we are going to get 3 equal to what? B. Therefore, our b is equal to 3. So here we can now replace our a and b with their values. Therefore, x plus 1 on x minus 1, this is just from the question, x minus 2 is the same as a, which is negative 2. So negative 2 on x minus 1. Then our b is 3 on x minus 2. Are we okay? So can we say that integral of this x plus 1, x minus 1, x minus 2 dx is the same as integral of the whole of this negative 2 on x minus 1 plus 3 on x minus 2 dx. So we have this, and when you look at this, this is now broken down into what a simple term to integrate. So we can now continue with this part and we can solve it very well. Are we okay? So now we can say that will be equal to integral of negative 2 on x minus 1 dx plus integral of 3 on x minus 2 dx. Looking at this part, you can integrate them separately. Are we okay? So this is what I've done, taking the integral of each side. So this negative 2 is a constant. It can come out giving me 1 on x minus 1 dx. The 3 can come out integral of 1 on x minus 2 dx. But we know that the integral of 1 on x minus 1 will be equal to what? Ln of x minus 1. The same thing, integral of 1 on x minus 2 will be ln of x minus 2. Integral of 1 on x minus 2 will be ln x minus 2. So can we bring it back here? So that will be negative 2. This will be ln x minus 1, since it is integration, plus c1, the first constant, plus this will be 3 ln of x minus 2 plus, let's say, a constant c2. So since 1 and 2 are both constant, I will combine them as a single constant, giving me negative 2 ln x minus 1 plus 3 ln x minus 2. The addition of this and this will give me a single constant. Are we okay? So this is the partial fraction approach for that question. So solving this, going through the partial fraction approach, you are going to finally reach an answer in this form: negative 2 ln x minus 1 and that. Example 2. Integral of x squared on x plus 1, x minus 1 all squared dx. how do we solve this? So from partial fraction, we can express this. So taking x squared on x plus 1, x minus 1 squared. Can we say it's equal to, now a will take the first part, which is x plus 1, plus b will take the first linear part of the square, x minus 1, and c will take x minus 1 square. This way. Are we okay? So in order to solve this, now the LCM here is x plus 1. Remember, x minus 1 can be found in s minus 1 square. So I'll just take the highest one, s minus 1 what? Square. Are we good? So this will now take care of that, and this will multiply this, giving me a multiplying x minus 1 all square, plus x minus 1 will come and take one of this, leaving x minus 1, x plus 1. So bx plus 1 multiplying x minus 1. Then this c will take care of the x minus 1 square. Then c will be multiplying x plus 1. Are we okay? Equal to that. So our x squared on x plus 1, x minus 1 square. Since the LCM they are the same, we can solve the numerator. So we can say our x squared is equal to a minus 1 square plus bx plus 1, x minus 1 plus cx plus 1. Are we okay? So we are to find the value of a, b, and c. The value of a, b, and c. What can we do here? When we take x to be 1, when x is equal to 1, x is equal to 1 will make a go to 0. Then since here b can also go to 0, and we'll get the value of what? C. So when x is equal to 1, I'm getting 1 square here equal to a multiplying 1 minus 1 square plus b1 plus 1, 1 minus 1 plus c, 1 plus 1. Are we okay? This will go to 0, this will go to 0, and that will be 1 on 2. So with this, I'm going to get 1 is equal to 2c. Then my c is 1 on 2. So we now know the value of c to be what? 1 on 2. Are we okay? The value of c is now 1 on 2. Let's try to find the value of the other parameters. So here we know c to be 1 on 2. When we say x is equal to negative 1, when x is equal to negative 1, what can we eliminate? From the equation, if it is negative 1, meaning b will go to 0, c will go to 0, and we can solve for what? A. Are we okay? So let's put in the value. That will be negative 1 square equal to a negative 1 minus 1 square plus our b negative 1 minus 1 negative 1 plus 1. And our c will be negative 1 plus 1. This will go to 0, or this will go to 0. And I'm getting 1 is equal to a negative 2 square. Negative 2 square is going to give me 4, which is 1 for a. And my a is going to be 1 on 4. Already I have c to be 1 on 2, and I've gotten a to be 1 on 4. I want to also get the value of b, so I can choose when x is equal to 0. Are we okay? So if x is equal to 0, then I have to put in the value of x to be 0. Now I know the value of a, and I know the value of what? C. So that will be 0 square equal to a, which is 1 on 4 multiplying x0 minus 1 all square. I'm looking for b. That will be 0 minus 1. That will be 0 plus 1. Then plus c, 1 on 2, 0 plus 1. So solving all this and making b the subject, my b is going to be 3 on 4. Are we okay? Therefore, the values of a is 1 on 4, b is 3 on 4, and my c is 1 on 2. So we can go back to the equation, plug them in, then solve for our final answer. Are we okay? So our final answer, can we say x squared on x plus 1, x minus 1 all square is the same as our a, which is a 1 on 4, x plus 1. Then our b, which is 3 on 4, x minus 1, plus our c, which is 1 on 2, x minus 1 all square. Are we okay? So first we can bring this part as x squared. We can integrate both sides because the question wants us to what? Integrate minus 1 square. So my integral with respect to the x. With this 1 over 4 will come back here, integral of 1 on x plus 1 dx, plus this 3 on 4, integral of 1 on x minus 1 dx, plus 1 on 2, integral of 1 on x minus 1 all square dx. Are we okay? So can we say the integral of this is ln, and the integral of this is also ln, but the integral of this is never a ln. So what do? We can do something about this. So first, here I can say my 1 on 4 ln of x plus 1 plus 3 on 4, that will be ln of x minus 1 plus 1 on 2. This is the same as integral of x minus 1 negative of that. Are we good? So if we want to solve this, we have to add 1 to the power, divide through by what? Negative 2 plus 1. And finally, I'm going to get 1 on 4 ln of x minus 1, that's plus 1, plus 3 on 4 ln of x minus 1, plus, with that, meaning if you solve, you are going to get 1 on 2. This is going to give us negative, multiplying a negative x minus 1. Here is going to give us negative 1. Are we okay? So we can further say the final answer is 1 on 4 ln x plus 1 plus 3 on 4 ln x minus 1. Negative, this negative will affect this. Then this will come down as x minus 1. Remember, they all had c plus c, so plus the constant c. And this is the integral of the function we solved for. Are we okay? Very simple. You just have to know your partial fractions and you are good to go. Example 3. Find the integral of x squared on x minus 2 x squared plus 1 dx. So first we have to express this with what? Partial fractions. So can I say x squared on minus 2 x squared plus 1 will be the same as, if you want to express this is linear, so we can get our a on x minus 2. Looking at this is not linear. It is x squared plus 1. and we cannot get any linear factors from this. So in that way, we are going to express it as b on bx plus c on x squared plus 1. Are we okay? Take note of this. How to express this one. It's very important to also get it that way. So we have our expression in this way. We can say equate x squared equal to this a will take this part, x squared plus 1, then plus bx plus c will multiply x minus 2 this way. So when we want to get the value of a, b, and c, so when x is equal to 2, this will run to 0. When x is equal to 2, that means 2 squared equal to a by a squared. That's going to be our 2 squared plus 1 plus b by 2 plus c, 2 minus 2. So this is going to be 4 equals, that will be what, 5. 2 squared is 4 plus 1, 5. So 5a. And because of this 0, it will run everything to 0, giving our a to be equal to 4 on 5. Now we have a to be 4 on 5. How do we also get 4? The other parameters. Looking at the equation, when x is equal to 0, this b will go, and we can find the value of what? C. When x is equal to what? 0. So when x is equal to 0, from the equation, I'm going to get 0 squared equals a. Do I now know the value of what? A. Yes, that is 4 on 5. So I'll bring it 4 on 5, 0 squared plus 1 plus bc, b by 0 plus c, and that will be 0 minus 2. Solving this, you are going to get your c to be equal to 2 on 5. And you can bring in when x is equal to 1. You can put in the value of 1 and put in the value of a, c, and you get your final answer. So that will be 1 squared will be 1. This a, which is 4 on 5. 1 squared, that will be 2. Are we okay? Here will be 2 plus b by 1. That will be what? Our b plus our c, 2 on 5. This will be 1 minus 2, which is negative 1. And when you solve for the value of b, your b is going to be 1 on 5. So with this, you have the value of a, the value of b, and the value of what? C. So you can do something about the equation now. Are we good? So let's see how best we can also solve. So now we can say x squared on x minus 2 x squared plus 1 is equal to our a, which is 4 on 5 by x minus 2 plus our b, and now b is 1 on 5. Are we good? 1 on 5 x plus c, 2 on 5. They were all by x squared plus 1. So can we further do some mathematics? This is equal to 4 on 5 by 1 on that, x minus 2, plus this 2 can be written as 1 on 5 x on x squared plus 1 plus 2 on 5 1 on x squared plus 1. Because this x squared plus 1 is dividing this plus it is dividing that from just simple arithmetics. Are we okay? So here, x squared on x squared plus 1. We can apply our integral, then our integral separately. And this is going to, with respect to the x, and the x. This is going to be 4 on 5, integral of 1 on x minus 2 dx, plus 1 on 5, integral of x on x squared plus 1 dx, plus 2 on 5, integral of 1 on x squared plus 1 dx. Looking at this, we can get ln x minus 2. By looking at this, the derivative of that is not equal to this. The derivative of x squared plus 1 will be 2x, but here is just x. So can we multiply through by a certain 2? We can multiply here by 2, then divide here by 1 on 2. Are we okay? So that this can cancel this. Now, the derivative of x squared plus 1 is that, meaning we can get ln of that. Are we okay? So which is going to give me 4 on 5 ln of x minus 2, plus this 1 on 5 by this will be 1 on 10 ln of x squared plus 1, plus 2 on 5 integral of 1 on x squared plus 1. It's one of the tan. So we know that tan inverse of x, the integral of tan inverse of x, when you solve this, we are going to get 1 on, the derivative of that. The derivative dy dx of tan inverse of x is going to be 1 x squared plus 1. Meaning if you integrate this, you should get back your tan inverse of what? X. Therefore, integral of 1 on x squared plus 1 is tan inverse of x plus your constant c. So this is the final answer for the question integral of x squared on x minus 2 x squared plus 1 squared. Thank you for watching this episode. Go through the video step by step and you'll get the understanding. Thank you.